Thank you all for being here and to listen to my talk on IMF data discovery and extraction. IMF is International Monetary Fund. And a little bit about me. So my name is Irina Klein, and I'm a graduate student at Illinois Tech studying data science. I'm very passionate about data analysis, and I have a background in business data analysis. So last summer, I worked on a financial data analysis project with Dr. Sou-Cheng Choi, and we worked with IMF data, and we discovered that the current API for automatic data extraction and the underlying structure of the data sets is quite complex, especially for unprepared users or non-technical users, such as economists or financial analysts. And today, I'd like to go over the data sets available in the IMF, the current method for automatic data extraction, and how we simplified this method in order to make it more available. And this is a joint work with Dr. Sou-Cheng Choi. We'll cover the data sets available in the International Monetary Fund. We'll look at the current API for data extraction, and then we'll go deeper into the our solution for data extraction from the IMF. So these are some of the data sets available in the International Monetary Fund. And the International Monetary Fund is an organization that provides advising services to its member countries. And out of 195 countries in the world, 190 are members of the IMF. And apart from advising services, IMF collects data from these countries. And the data it collects includes various macroeconomic indices such as GDP, employment, unemployment rates, consumer price indices, and many others. And here's a list of some of the data sets available on the IMF. There are various methods to get this data, and the first one is the web query interface, which is an online tool to have a quick overview of the indices, where the user specifies the time frame, the countries they're interested in, and it allows to quickly evaluate what the index values are, and there are also some visualization tools it provides. Then there is the bulk download method, which allows you to download a CSV file with all the data and analyze large amounts of data. However, in order to update new periods, that would have to be done manually. And then there's the IMF data mapper, which is an online application, and there's also an app, and they both work in the same way. So it's an online application where you can see summary statistics and some visualization of the data. And again, this is a useful tool for a quick overview of the situation, some comparisons between countries, and chronological trends analysis. And the last method listed here is the JSON RESTful Web Service API, which is a tool for automatic data extraction. And it can be used with Python or R, and the data that is downloaded is in the format of JSON files. And now we'll look at each of these methods in a little more detail. So the web query interface, this is how it looks, and you could specify the time frame, the countries, and the indicators you're interested in, and see data in either tabular format or a line chart. And here we have the GDP values for the last 5 years for the US, UK, and Germany. This is the bulk download method, and for each data set available, you could click on the little button next to it, and this would send a request to download that whole data set in bulk. After the request is processed, you would get an email, and then you would be able to download the a zip file containing the CSV files with the data and the metadata. This is the IMF data mapper, and it provides some visualizations, so you could analyze either country to country or the chronological trends of real GDP. The last method we mentioned was the JSON RESTful Web Service API, which is used for automatic data extraction, and it downloads JSON files. So what is a JSON file? It's a file format that allows to efficiently, that is used for efficient transmission of data between web applications, and it consists of key value pairs and arrays. An example of a JSON string is included here. So this string is taken from one of the IMF's data set, the International Financial Statistics dataset, or IFS. And as I said, a JSON string consists of key value pairs. So the key is @value, and the value is the string AF. And the next key is description, and the value is another so-called nested map structure, also consisting of key value pairs. And the description shows us that this string AF stands for the country name Afghanistan. And RESTful API is a interface to interact with resources on the web using the so-called REST design pattern, and it allows to efficiently for resources on the web to interact efficiently and in a standardized way. So the user can send a request to a server to read some data, and then the server would send a response back. And there are some examples of how to use IMF's JSON RESTful Web Service API online. Additional examples are provided in my GitHub repository, and the link to the GitHub repository will be shown a little later. So before we look into examples, there are some useful definitions that we should cover. In the IMF, series refers to the data set. So for example, the International Financial Statistics data set, or IFS, is a series name. Indicator refers to the economic index or metric, for example, GDP. And dimension refers to the metadata of an indicator. So it's a way to categorize values. So for example, GDP, the dimensions are area or the country, US, the frequency, for example, quarterly GDP, and the period, for example, of the quarterly GDP for 2020. There are also some other useful definitions that we should mention before moving on to examples. So metadata, as I said, it's a set of data that describes other data. We'll also talk about Python packages, which is a collection of installable reusable Python code where a user can install the package and use it for a specific task. A data frame is a two-dimensional tabular format, and a pandas data frame is a data frame created with a pandas Python package. Now we'll talk a little more about the JSON RESTful Web Service API that's used for automatic data extraction from the IMF. As I said, it loads JSON files, and this is how a JSON file could be visualized. So here we have an example of metadata structure in the GAFSR data set, which is government financial statistics revenue data set. And this is the area dimension. We can see on the top here that the dimension ID is CL area GFSR, and the dimension name on the left is geographical areas. Then each country code is listed, and for each country code, we are given a description of what country it stands for. Then let's look at an example of how data is structured in the IMF's JSON files. So on the top, we have some metadata, the frequency, the country, and the indicator code. And at the bottom here, the observations are given as a list. So these are real GDP values for each time step in the year of 2022. Now we'll look at an example of how this data could be exported using the JSON RESTful API. And we'll analyze the quarterly change in real GDP for the US. And in order to do that with the JSON RESTful API, the user must know the structure of the underlying data set, what the dimensions are, and how to access them, and also specify the necessary dimensions. So for example, the index code that we're interested in, the country codes that we're interested in, and then knowing that the user would request data using the compact data method. There are various methods available to interact with the JSON RESTful Web Service API. We'll not be covering those in detail because later I'll show an example of how this process could be simplified. However, in the GitHub repository, there is a description of each method. Now let's look at an example of how this data could be accessed using the API. So this is a Python notebook, and first we import the necessary libraries. We specify the series that we're interested in, the frequency and the country code, and the time frame. Using the data structure method, we will search for indices related to GDP. And then this cell here outputs all the indices that are related to GDP. Again, I won't be going into the specifics of how it works, but the user must know the structure of the data set in order to access this data. So this is the list of the index codes and their description. We are interested in the real GDP, seasonally adjusted in domestic currency. So we specify this code here. Then using this compact data method, we send a request to the IMF server to retrieve this data, and then we process it and turn it into a pandas data frame. So this is the output. This is the output data frame. Having done that, we can now analyze the quarter-on-quarter change using the pandas %change function. And after that, we can plot this data using matplotlib. Here's the result. And we can observe the real GDP trend going upwards, and with a dip here in the second quarter of 2020, most likely related to the pandemic. And then we save this data frame to a CSV file. So this is an example of how JSON RESTful API is used to retrieve data and analyze data. The user must not only know the structure of the data set, but also understand well the index codes and the country codes that need to be specified in order to retrieve it. And given that the structure of these datasets varies from series to series, it might be too complex for an unprepared user, and it would require a lot of time to understand the different dimensions and how to access this data. So there has been work on making this process simpler, and there's a number of packages that were created in order to hide these complexities from the user. And the first one, the IMF data R package, it allows to search through series and index codes and output data giving series names and given index codes and other parameters. It is, however, not actively maintained. The second data Punji IMF package, it allows to load data and metadata given index codes and other parameters again. However, it's not very intuitive and there's very little documentation provided. The IMF Pi package, it allows to efficiently search through the data sets and the index codes and download data for the direction of trade statistics into pandas data frames and visualize it. The Pi IMF package also allows to search through data sets and index codes. However, it doesn't install correctly and there's very little documentation. And the last package mentioned here is our solution to the problem outlined before, which I'll talk now in more detail. So the IMF data Pi package, we propose creating this a wrapper package that would mask the complexities of the JSON RESTful API, and it would provide an intuitive way to search through index names so that the user wouldn't have to know the index codes and specify those in the request. The package should have a detailed and searchable documentation, and the functionality should be ensured with unit tests because, as I said, the structure varies from series to series, so one approach might not work for another data set. The current work on the package is released in this GitHub repository, and the package is structured in an object-oriented way with child classes inheriting functionality from parent classes. So each child object is a series, and this way we can efficiently keep the same functionality for the series where the structure of the data set is similar and adjust the methods for those data sets where the structure of the underlying JSON files is different. To install this package, the user would have to run the pip install command. And now we'll look at an example of how to extract real GDP quarter-on-quarter change using the IMF data Pi package. So it's the same example we looked at before, only with the package. So first we install the package using pip install. Then we import it, and we also import pandas in order to for the percent change function in order to analyze the quarter-on-quarter change. And now, instead of specifying the index code, the user has to input a search term. So for example, we know that we're interested in GDP, so we specify that string here. And then using the download data method, all the data that where the index matches our search term will be downloaded. So the resulting data frame contains values for all indices related to GDP. And this way, the user wouldn't have to, first of all, understand the structure of the JSON files, and second of all, know the specific index codes, which are shown here on the right. Since we know that so as I said, all the different indices related to GDP are downloaded, and in order to view which indices we've downloaded, we can look into the metadata file that's also downloaded with the download method. And we know that we're interested in real seasonally adjusted GDP. So we filter our data frame to contain just the real GDP. We then visualize it, we then perform the percent change function to analyze the quarter-on-quarter change, and we visualize it in the same way using matplotlib. So we've designed an extensible software with the IMF data py package in order to discover and extract IMF data, and the ongoing work includes creating comprehensible documentation, implementing robust input parsing, and testing the package with unit tests for each series, because as I said, the structure of different series is different. We will also add summary and descriptive statistics for the data sets that are loaded, so that the user could have a better understanding of what kind of data is loaded, and also we are interested in collecting more economic and financial use cases using IMF data py. These are our sources, and thank you for the attention. I'd also like to say that I hope that this package and the future improvements would help economists and financial analysts, or anyone interested in working with macroeconomic data, to have an easier access to it and to make it more available. The GitHub repository is shown here, and also the PyP page where you could see how to install the package. If you have any questions, please let me know, and feel free to send me an email if you have any suggestions or questions on how to work with the package or about the IMF data in general.